Have you ever looked at what AI can do and just wondered how? What's going on in there? Well, it's not magic, and it's not just a bunch of code. It's actually something way more fundamental, something beautiful. It's math. And today, we're going to pull back the curtain and decode it together. I mean, think about it. We see AI creating art that's just breathtaking, or even helping doctors diagnose diseases. It's so easy to just shrug and call it magic, right? But the reality is so much cooler. It really is all about the math. So let's ask that big question. What is really going on inside that black box? To help us out, we're going to use a fantastic book called Mathematics for Machine Learning as our guide. Seriously, you can think of this thing as our key to unlocking the whole AI magic box. It's going to let us see the elegant, powerful math that's really running the show. And you know what the best part is? This book isn't written for some PhD-level genius. Nope. It's for anyone who's got a decent handle on their high school math. It's all about building a bridge from what you already know to the really big ideas in machine learning. It makes this stuff accessible, and that's why we're using it. Okay, so if we really want to understand how a machine thinks, we first have to learn its native language. And that language, it's built on one single powerful idea, the vector. So what on earth is a vector? Well, at its simplest, it's just a list of numbers. But here's where it gets interesting. Depending on who you talk to, you get a slightly different perspective. A computer scientist, they see an array of numbers. A physicist sees an arrow, with a direction and a length. A mathematician sees this abstract object you can add and stretch. And for an AI? Well, a vector is all of those things. It's the universal translator for data. Let's make this real. Take a look at this. We've got some data about a person named Aditya. He's 36, he's male, and he has a master's degree. How does a computer read that? Well, we turn it into numbers. Age 36 is just 36. We can represent male as 0. We could assign MSc the number 2. And boom. Just like that, we've taken all these different kinds of information and bundled them into one clean package the machine can actually work with, the vector 3602. All right, so that's a person. But what about something way more complex? Let's take this idea of vectors and matrices and see how it can be used to do something that feels like pure science fiction, teaching a machine how to see. We're literally going to watch an AI use this math to take an image apart, understand it, and then rebuild it right in front of us. So here we have it, a classic photo of Stonehenge, right? To you and me, that's what it is. Rocks, sky, grass. But to a computer, it's something totally different. It sees a massive grid of numbers, a matrix. Every single number in that grid just represents the brightness of one tiny pixel. It's a completely alien way of seeing. So you gotta wonder, how can a machine make any sense out of that giant wall of numbers? Well, the answer is this really elegant trick called matrix decomposition. I love this analogy. Imagine you've got a song. You can break it down into its separate tracks, right? You've got the drums, the bass, the vocals. That's exactly what matrix decomposition does to an image. It breaks it down into its simplest, most essential pieces. And here's the first and most important piece of that puzzle. This is what's called a rank 1 approximation. Yeah, it looks super blurry, I know, but look closer. It's captured the most fundamental information in the entire picture, the basic shapes, the general layout, the skeleton of the image. Okay, now watch this. We're going to add just 2 more of those fundamental pieces back in. See that? All of a sudden, the image starts to sharpen up. You can really make out the outlines of the stones now, the difference between the ground and the sky. The details are starting to pop. And now, look at this. With only 5 of these mathematical building blocks, we've got a totally clear, recognizable picture of Stonehenge. Think about that. This isn't a copy-paste of pixels. It's a complete reconstruction built from just a handful of simple mathematical patterns. But here is the part that just blows my mind. To create that incredibly clear image, the AI only needed 0.6% of the original data. Let that sink in. This isn't just about seeing an image, it's about incredible efficiency. It's one of the most powerful forms of data compression you can imagine, finding that tiny essential signal that's buried in an ocean of noise. That technique, matrix decomposition, is just one tool in a massive toolbox that machine learning engineers use every day. So let's peek inside and see what else is in there. So this whole toolbox is just full of these amazing mathematical ideas. We just saw linear algebra and matrix decompositions with the Stonehenge picture. That's the math of grids and breaking things down. But you've also got stuff like vector calculus, which is basically the engine that lets a model learn and get better. And since the world isn't perfect, you absolutely need probability and statistics. That's what lets an AI deal with messy, uncertain data and make smart guesses. Every single one of these tools has a critical job to do. Okay, so we have the tools. Now, what do we build with them? The book lays it all out, saying they really build 4 main pillars of machine learning. First up is regression. That's just a fancy word for predicting a number, like guessing what a house will sell for next year. Then you've got dimensionality reduction. That's exactly the Stonehenge trick, compressing data down to what's most important. Third is density estimation. This is all about finding hidden structures, like finding natural groups of customers who all seem to like the same things. And finally, number 4 is classification. This is the decision maker, the one that sorts things into buckets, like spam or not spam. So, okay, we've seen the toolkit and the 4 big things it can build. But let's step back for a second. Why does any of this actually matter? I mean, why should you or I care about the math that's humming away inside an AI? Well, here's the thing. The goal isn't to turn everyone into a mathematician. It's about something way bigger. It's about literacy. It's about being able to understand, at a basic level, the language of a technology that is fundamentally changing everything about our world, from our jobs to how we talk to each other. And the authors of the book we've been using say it perfectly. They write, as applications of machine learning become widespread in society, we believe that everybody should have some understanding of its underlying principles. You see, this isn't just about knowing stuff. This is about empowerment. And that brings us to a final, pretty deep question to leave you with. If an AI's entire reality is built on the clear, logical, structured language of mathematics, what are the real limits of what it can ever truly understand? Can a system built on numbers ever really get the messy, beautiful nuances of human experience? I don't know the answer, but it's something we should all be thinking about. Thanks for diving into the mathematical heart of AI with me today.